Hello everybody and welcome to your very first lesson in geometry. Geometry happens to be my favorite of all the sub-subjects of mathematics. Geometry is my favorite. A lot of times people think, hey, geometry, it's all about shapes, and I'm great with shapes. I can identify the pentagon, the circle, what do we have here? A hexagon, parallel lines, octagons, angles, right triangles, isosceles triangles, dodecahedrons, rhombotruncated icosahedodecahedrons, all sorts of shapes. But this year, we're going to take your understanding of shapes and we're going to expand it in two ways. We're going to take a more sophisticated look at shapes. Like in nature, you have, say, the swirl pattern on a snail, and we're going to look at how that relates to this golden ratio. We might take a look at basic tessellations, like this tessellation of hexagons, and see how that relates to this artistic picture of, what do we have here? Lizards twisting around. And then we'll take a look at how mathematics and geometry in particular creates such wonderful patterns in nature and creates wonderful patterns in movies. But geometry is not really just about shapes. What geometry really is it's a course in logic. And our field of play is shape, but it's really a course that dives deep into how you think and how you justify these thoughts that you have. So, today is your very first lesson. You're going to take notes for yourself on paper, and I'm going to look at these notes tomorrow. So I really need you to get out a fresh, clean sheet of paper that's only going to be used for math and take good quality notes where you write things down and you draw some pictures. Some days I'll give you guided notes if there are a lot of pictures involved. Other days I ask you to take notes. So please take good quality notes. I'm going to look at these tomorrow to see how you take notes and give advice if I feel you need it. So let's start. Like I said, logic is the game of geometry. Shape is the field of play. So when we go into looking at shapes, there are really two different ways we're going to look at shapes. We're going to look at shapes in general. Isosceles triangles, right triangles, angles, circles with different angles inside of them, polygons where we break them up into triangles. But we're also going to look at shapes where measurements are attached. So for example, if these are parallel lines and this is 70 degrees, we're going to want to find all the measurements that you can find of all these angles. We're going to look at right triangles and how if you know two sides, you could find the third side. We're going to look at right triangles where if you know only one side in an angle, how do you find the third side? And if we're putting measurements on shapes, we're going to look at if we put these shapes on the coordinate plane you worked with last year in algebra. So there's a lot involved, and we always want to have two perspectives, just a shape in general floating around in space and a shape where we have measurements that we've attached to it. So to start out our discussion here, we need to start out with some vocabulary so we can communicate with each other. There are a lot of terms I'm going to use. These are just a small scattering of some of the terms you'll hear this first unit, and I need to make sure that when I say perpendicular, you understand everything that's implied and things that are not implied. So let's get started with a little bit of terminology. Okay, so we'll start out with the most basic of all shapes, a point. And a point really is not a shape at all. It looks like a little circle, but it's an exact location in space. We consider points to be zero-dimensional. They have no length, they have no width, they have no depth. It's just a location. And I know when I draw a point, you say, that's a circle, but it's really not. It's just an exact location. When we name points, we give them a capital letter. So this would be called point P. And here's an example I'd like you to draw, and I'd like you to write out the little phrase that goes with it. So for example, if I had this drawing here, I could talk about point B as being between points A and C. And notice when I just have a capital letter A and a capital letter C, those are implied to be points. By the way, feel free to pause the video if you need to catch up. I only get 15 minutes, so I I will talk quickly, but pause the video and write down what you need to write down. Next term, and we only have 3 terms we're going to go through today. I don't want to bore you to death with our first nights of notes, would be a line. And a line is a segment that extends forever in both directions. So lines go forever. You know, when your teacher asks you in English class to underline a verb, that's really impossible because lines would go on forever in both directions. Now, when we talk about lines, we name those lines by 2 points through which the line passes. So you'll notice that this blue line passes through points A and B. And we would call this line AB. Notice we have a little line symbol above it. Or you could call it BA. The order of the points is not important. It doesn't have to be alphabetical. You don't have to name them from left to right. Either one would suffice. And like I alluded to earlier, lines have infinite length. They go on forever. And here is an example of a line, kind of like we talked about for a segment. So in this example, we have 2 lines. We have this first line here. We have this second line here. And one way I might write about lines is I would say line AB. Notice line AB is this one. And line CD, that's this one, intersect or meet at G. And again, it's just a capital letter, and that means it's point G. Now, by the way, I called this line right here line AB. I could have called it line BA. I actually could have called it line AG, and it would be the same since lines go on forever. So lots of ways to name lines. The last term, and then we'll get into some good fun math, I promise, is a segment. And a segment is a part of a line with 2 distinct endpoints. So segments have a start and an end. And so this segment here would be called segment YZ or segment ZY. Again, the order is not important, but notice the symbol above it doesn't have arrows on it. It's not a line, it's a segment. So segments have a finite measurable length. I could talk about the length of segment YZ as being, I don't know, like 3 inches. I could never talk about the length of a line, but I could a segment. And so an example of where you might see segments written about in this class is I might say, oh, look at this picture. I might say segment WX, from W to X, must be shorter than segment VZ. That is clearly the case. WX is a part of VZ, so it's got to be shorter. And again, since these are segments, I can talk about length. But if these had arrows on them and they were lines, well, all lines are infinite, so you can't say one line is longer than another. So let me start out with a little kind of vocabulary check on you. See if you're able to name this blue line, not segment, but this line, 12 different ways. And if we were in class together, I'd have you list them with your partner, but since you're not, just see if you can come up with a list, 12 different ways. And I'll get you started. You could call this line, line AB. So line AB could be the name of this entire thing, or you could call it line BA. Remember, order doesn't matter. So I just did 2. See if you can knock out the rest. So why don't you pause the video, try coming up with the other 10, and then come back and check. Hey, welcome back. I hope you paused the video. Don't just sit there and run through it and let me do all the work. See if you can do this. I came up with line AC and line CA. I came up with line AD and line DA. My next batch, instead of starting with A like I did here, I started with B, so I got line BC and line CB. I also did line BD and line DB. And my final name for this line, I started with A, I started with B, I started with C. Line CD and line DC. Great. So those were just practice with naming, but let's get into some numbers. We've talked about shapes floating around there, but now let's attach the measurements to shapes. There are 3 examples I want to work through in this problem. So here's your first example. Why don't you take a second, write down the directions, find X, draw the picture, and then when you're all done with that, come back to the video and let's talk. Hey, welcome back. So I want to make sure we understand exactly what's going on in this. I see segment DE, and segment DE has a length of 3x plus 2. Now x is some number, like if x was, say, the number 11, DE would be 3 times 11, 33 plus 2. DE would be 35. Segment EF is length x plus 5. And the final segment, the big one, segment DF, is called 6x minus 5. So when you look at that, you ought to be able to come up with an equation relating these three measurements to each other. Is there any evidence that this 3x plus 2 should equal this x plus 5? And the answer there is no. There's no evidence at all that those should be equal. There's no indication that these are equal segments. If you look closely, though, you'll see that this 3x plus 2, this red segment, and this x plus 5, this blue segment, should add up to be the purple segment, 6x minus 5. Do you see that the red plus the blue equals the purple? And so if I come down and I express that not through my picture but through algebra, I could say 3x plus 2, the red segment, plus x plus 5, the blue segment, should give me 6x minus 5, the purple segment. And now it's simply a matter of algebra. I'm going to clean up my left side, add my x's together, add my constants together. I'm going to get my x's alone, and I get x equals 6. So hopefully you got that. All right, let's look at a new problem. Go ahead and copy the problem down, write the directions, draw the picture, and then when you're done with that, come back to the video and let's talk. Hey, welcome back. Hopefully you paused the video and you copied these things down. Now this time there is a lot of writing, but not a lot drawn in our picture. So we know A is between C and T, and we can see that in the picture. See how A falls between C and T. We know CA is 2x minus 3. So I'm going to go ahead and label this picture. 2x minus 3 is the length from C to A. I know AT is x plus 7. So the length from A to T is x plus 7. And I know CT, the whole thing, is 5x minus 18. So I have to find where I wrote that. Oh, there it is. 5x minus 18 is the whole thing. And again, this is what the picture looks like, but we can get an equation, an algebraic equation based on that picture. The red segment plus the blue segment should equal the whole purple segment. And this is where you get to show off your algebra skills from last year. You can solve that equation. Clean up the left side, get your x's together, and solve. It said to find x. That's exactly what we did. One last piece, one last problem. Here you go. Go ahead and pause the video, draw the picture, and come back. Hey, everybody. I hope you did that. I hope you paused the picture, you drew it, and you're back now. Let's read what we have here. Suppose O is the midpoint of DG. Now, midpoint is a special word. We saw this show up in our homework the other night. That means that O is on line DG, but it's the midpoint. Does this look like it's the midpoint? Well, no. I mean, that doesn't look like it's the midpoint. The midpoint would be in the middle. So you want to make sure you put O right smack in the middle. And I know the distance from D to O is 2x minus 4. And the distance from D to G, now be careful, D to G is 5x minus 16. And I ask, how long is DG? Well, let's set up an algebraic equation. Well, we're missing this piece right here. How long is OG? Well, actually, I know how long OG is. If O is the midpoint, that means that this segment right there, DO, is equal to this segment, OG. By the way, hash marks mean that the segments are equal. If this has one hash mark and this has one hash mark, it means they're equal. So if this is 2x minus 4, this is also 2x minus 4, and that gives me this equation. 2x minus 4 doubled is 5x minus 16, And there's your answer.